Lewis structure are diagrams that shows the bonding between atoms of a molecule and the lone pair of electrons that may exist in the molecule. Steps in writing or drawing Lewis structure. Number 1, choose a central atom. The central atom is usually the least electronegative atoms in the species. Please note, hydrogen can never be a central atom, and also fluorine. Let me just give us a rundown of the first rule, then I can give us the second. If you want to draw a structure of any compound, Lewis structure, we said, is a diagram that shows the bonding and the lone pairs of electrons that may exist in such compounds. For example, if I have, let's say, I have something like this, ammonia. I want to get the Lewis structure of ammonia. If somebody asks you to draw the structure of ammonia, first thing first, you need to locate the atom that will be at the center. Is it not so? Now, nitrogen is at the center, right? Now, these 3 hydrogens are flanked on the side. We have this. For example, I'm just giving, this is not the Lewis structure, I'm just showing us something. Now, I'll first of all get the central atom, after which I'll now join the peripheral atoms. Class, there are atoms that can never act as a central. The first one is hydrogen. Why? Because hydrogen can only hold one bond. Right? If something can only hold one bond, you're not fit to be at the center. Because center can have different bonds, right? Now, fluorine can also be at the center. Because the central atom is always the least electronegative. And fluorine is the most electronegative element in the periodic table. So anytime fluorine is combined with any other atom, the other atom must be the central. Because fluorine being this is the most electronegative element in the periodic table. And this guy cannot be the central atom. Right? So take note of that. Step 1 is to get your central atom. Rule number 2, or step number 2, calculate the number of bonding / shared electrons, which is X, and the number of bonds. By dividing X by 2. Now, the reason why we are doing this is because if I want to draw the Lewis structure of a compound, structure definitely means I need to know the various ways the central atom is bonding to those other atoms. So the first thing is for you to identify the central atom, put it at the center. The next thing I'm going to do is to calculate to know the exact number of bonds that compound is going to have, so that I'm not going to give it less number of bonds. I'm not going to give it more number of bonds. So for us to do that, the number of bonding electrons or shared electrons is what we call the X. Now, for me to now know the number of bonds present in the compound, whatever the value of X is, I'll divide it by what? 2. Now, what is the formula to solve for X? X is equals to V minus what? A. Now, where V is sum of valence electrons minus charge. I'll explain that. Please add this. V or A is sum of valence electrons minus charge. Now, what does this mean? It means that, imagine I have something like this, CO3 2 minus, and I'm asked to give the Lewis structure for this. First thing first, I'll say, for me to draw the structure of this guy, I need the central atom. In cases like this, I don't really have to stress myself looking through the periodic table. Now, we have 2 elements, carbon and oxygen, is it not so? And out of these 2 elements, one of them is appearing 3 times, and one of them is appearing how many? It's very obvious that this carbon is the one holding this oxygen. Right? Now, if I don't want to do it that way, between carbon and oxygen, which of them is more electronegative? More means the one that is more to the right, but oxygen is more electronegative than carbon, is it not so? The one that will be the central atom is always the less. It's always the what? So since oxygen is more electronegative than carbon, which of these will be the central atom? So I'll come here, I'll put carbon. Carbon is my central atom. Now, I want to know the total number of bonds this compound would have, because I can't just look at this compound and say, hey, this guy is going to have 3 bonds or 4 bonds. Now, to you, you might say, since we have 3 oxygen, there is going to be 3 bonds, right? But there are cases where a compound can have a double bond or a what? A triple bond. So you have to calculate to know the number of bonds present here, and that's what we are doing here. Now, number of bonds is calculated by first calculating the number of bonding or shared what? Electrons. And I gave us a formula for that. X equals to V minus A. Now, what is our V? I'll come here and say V A. Please just pay attention and stop writing. V is a sum of the octets or duplex electrons. Sum simply means everything. Now, octet simply means that, class, remember that for any atom to undergo bonding, it always have an expectation. The expectation is to attain octet configuration also. So apart from hydrogen, helium, lithium, and beryllium, I gave all those exceptions, right? Every other element in the periodic table will attain 8. Is it not so? Class, this V is constant. Any element that is present here, value for each element is going to be 8. Or each atom is going to be 8. Carbon, the value is going to be what? 8. Because carbon, if carbon should undergo bonding, carbon is going to attain octet configuration. Is it not so? So the theoretical octet for carbon is going to be what? 8. Plus, oxygen is still going to attain octet configuration. Is it not so? So the theoretical octet for oxygen is still going to be what? 8. How many oxygen do we have here? So this becomes 8 times what? 3. The reason why each element is having 8 is because every element undergoes bonding to attain octet or duplex configuration, right? Apart from hydrogen and helium, lithium and beryllium, every other element, the V for each atom, V will always be what? 8. So that one is constant. 8 times 3 is 24, plus 8 is what? Please look up. Now this A, we said it is sum of what? Valence electron minus what? Class, I'm still going to break this guy further. Class, you may not really know the valence electron for each atom. But the valence electron for each atom is the same thing as the group number of that element. Same thing as the what? So when they say sum of valence electrons, you're going to say, for each one, what is the group number of that element? Because the group number of carbon is the number of electrons on the what? Outermost shell. Class, what is the group number of carbon? That means the number of electrons on the outermost shell of carbon will be how many? 4. What is the group number of oxygen? 6. I'm going to draw the periodic table after now. That means the number of electrons on the outermost shell of oxygen is how many? How many oxygen do we have here? Minus. What is the charge there? If you go and remove the charge, you fail it. Minus is what? 6 times 3 is what? Plus 4. 22. 22 plus, because this is now going to be plus, right? So that A will now become what? So now look at this. So for this particular element, or for this compound, our X becomes 32 minus what? X equals to what? 8. Now, this is the number of shared electrons. What do I mean? This is the number of electrons that carbon and 3 oxygen will share in this compound. Now, for me to find the number of bonds present in this compound, I'll divide this guy by how many? So the number of bonds present here will be X divided by 2 is equal to what? So this guy is going to have how many bonds? 4 bonds. So I'll come here, put carbon at the center. How many oxygen do we have there? Spread the oxygen across the center. We have the first one, the second one, and the what? Now, remember, at least I must use one bond to join those guys, right? A single bond is a necessity, but double bond is not a necessity. Every compound you see, there must be a bond. At least how many bond? One. I'll come here, I'll put 1, 2, and what? Class, how many bond do we have here? How many have I used so far? It means that this guy is going to have a double bond. Is it not so? I'll come here and put this here. So this is actually, we are not done yet because the rules or the steps are not complete, right? But based on the first 2 steps, this is what it means. You understand? So the X, I've shown us how we got the X, the V. Let's take it to step 3. Let me actually throw more light so that since I'm recording it, let me throw more light on how to get the valence electrons, right? Because if we don't really know how to get the valence electron, it's going to affect us. So please look up. For A, we said A is sum of valence electrons minus what? If a compound is neutral, here becomes what? 0. Take note of that. Please note, for each atom, the valence electrons equals to their group number. The valence electrons equals to their group number. Now this is 1A. I'm using A. 2A. 3A. 4A. Now look at this. So I'm just going to leave this in here. I said note. Now for the A, we said that A is obtained by saying sum of the valence electrons minus charge. Now, if I leave it as valence electron, many of us may not really know valence electron for the respective element. But it's very easy for us to actually tell the group number of such. This was what they taught us in secondary school, just that I added the A. In secondary school, they only say 1 to 8, which violates the IUPAC and the CAS way of numbering it. So I'm using A. So hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Now, you shouldn't bother yourself about the metals. Mostly, Lewis structure is mostly seen for non-metals, right? Majority of, let's say 99% of Lewis structure is only drawn for non-metals. Metals is not always included that much. So take note of this. So anytime we say sum of valence electrons, sum simply means go to the compound, check how many of such elements are occurring. For example, here, carbon is in group 4, so the valence electron for carbon is going to be 4, plus oxygen is in group 6. The valence electron for oxygen is 6, but it's happening how many times? Times 3. So that's how we are going to get that. Now let's look at our step number 3. Draw the skeletal structure of the compound showing the atom's connectivity. Draw the skeletal structure of the compound showing the atom's connectivity. Connect the atoms, continuation. Connect the atoms via single bonds first, comma. If there is a leftover after connecting all the atoms with single bond, you can now introduce a multiple bond. Now, this particular step is what I did previously, right? In the case of this CO3 2 minus, we had earlier solved for the X for this guy, which is V minus A, and we got our X to be 8. When you divide this guy by 2, we got this guy to be 4. It means that this compound has 4 bonds. So once you've done these calculations, the next thing you're going to do is to start drawing the skeletal form. Skeletal simply means without the bonds. I'll put carbon at the center. I'll place O here. All right. Now, I have 4 bonds. I need to connect this central atom to these other atoms using a single bond first, because it's compulsory that atoms are bonded to each other using a single bond. If I put this here, put the first bond, put the second, and put the third. Out of these 4, I have used how many? 3. Remaining 1, right? So I'm now going to come here, either place the bond here, right? Or I'll place it here, or I'll place it here. Why? Because the 3 of them are all oxygen, is it not so? What if we had another atom here? I'm going to talk about that later. Right? But for the fact that 3 of them are same atoms, right? If I put it here, it's equivalent to putting it here. So that's basically what that step is telling us. Step 4. Complete octets around each atom. Complete octets around each atom using dot electrons, except for hydrogen, which is usually satisfied with just a bond. Except for hydrogen, which is usually satisfied with just a bond. So now, still using this example here to explain that. So that now step 4 says, we've gotten the skeletal form, we've completed the bonds. Let me put this bond up here. Now, we need to complete the octets, because the reason why atoms undergo bonding is because they want to attain octet configuration. So this time around, I'm going to use dot electrons to complete the octets. Now, for me to do that, I'm going to start from the outer atoms, peripheral atoms, before coming back to the center. Class, each of these bonds you're seeing has 2 electrons. Each bond has how many electrons? 2. One at the one edge and one at the other edge. Is it not so? So far, this bond, class, this bond is counted for the 2 atoms that are holding it. The 2 electrons in this bond will be counted for carbon. It will also be counted for what? Oxygen. So far, since oxygen is holding just one of these bonds, right? It means that oxygen is having just how many electrons? 2 electrons. How many is remaining for this guy to become 8? 6. I'll add those electrons in pairs. So I'll come here. I'll say 1, 2, 3, 4, 5, 6. I have completed the dot electrons, making this guy to be 8. I come down to this other oxygen. How many bond is attached to this oxygen? How many bond? 1 bond. Each bond contains how many electrons? So this oxygen already has 2 electrons, right? By virtue of having this bond. Is it not so? So for me to take this guy to octet, octet is 8. Is it not so? How many electrons will I add to this oxygen to make it 8? 6. Once again, I'll add it in pairs. 2, 4, 6. I come down to this guy. How many bonds is this oxygen having? 2 bonds, right? Each bond contains how many electrons? So it means that so far we have 2 bonds here, right? How many electrons is present in these 2 bonds? So oxygen is having how many electrons? How many is remaining to make it up to 8? 4. I'll put it 2, 4. Can choose to put it up, but I just like my stuff being neat, right? So that's why I balance it symmetrically. Now, let's look at the central atom. Central atom should always be the last. How many bonds is this carbon having, class? Carbon is having 4 bonds. 1, 2, 3, and 4. Now, this guy is having 4 bonds, class. 4 bonds comprise of how many electrons? It means that I am not going to add any electrons to this guy. It's complete. So that's step number 4. It's done. Number 5 step says, check to see that the number of electrons in the molecule is equals to A. Check. Now, you have completed your Lewis structure. What are the steps you need to carry out to ascertain that what I've done here is correct? The value for this compound, the value we got for A was what? 24. So we are going to count the number of electrons, both the one inside the bond and the one we placed as a dot. We want to confirm if this guy is equal to 24. It's a must. Once you're done drawing your Lewis structure, you have to confirm. Now, the electrons, both the ones in the bond and the ones I placed as a dot, I have to count it. If it's not giving me 24, I'm not going to submit my script. That means I have missed it out somewhere. So let's look at this. Let's count it. This is 2, 4, 6. I believe you know a bond contains 2 electrons, right? 8, 10, 12, 14, 16, 18, 20, 22, 24. So since the electron is 24, that means I'll now breathe like I'm correct. Now, number 6 and the last, place any leftover electrons on the central atom. Even if doing so will result in an expanded octet around the atom. Even if doing so will result to an expanded octet around the atom. This part is very, very important, and I would like everybody to pay attention. If you noticed, listen. There are cases where, imagine we have something like this. Imagine a case where we have something like, here is 26. And after you have placed electron here, you place electron here, you place electron here, and carbon is having 8, right? And then you count the total number of electrons. What you're having is, what your A is giving you 26, right? But what you're counting here is what? 24. How many electrons is left to make it up to 26? 2. You must add that 2. Is a what? That is why they said any leftover, you have to place it. Where are you going to place it? Central. Remember, you can only touch the central atom after you have done what you're supposed to do to the what? Outside. On no account should you touch the central atom if this guy has not attained octet yet. Do you understand what I'm saying? Imagine here now was 6. And you now come and you have 24. Right? And as a result of your own mistake, you did not complete this guy to be 8. And you jump and put 2 here. You fail that question. You can only place something on the central atom, electron here, if this one is 8. Right? The outer atoms are all complete. You know so? Any leftover will now be placed on the what? Even if doing so will result to this guy having expanded what? Now, if you place 2 electrons here, for example, it's not correct. I'm just giving you an illustration, right? Let's assume I place something like this here. This carbon is now having 10 electrons. It's now having how many? This is 2, 4, 6, 8. Plus this is now how many? And what is octet? Octet is how many electrons? 8. So take note of that. All right. Now, class, listen to what I'm about to say now. Class, if you're writing Lewis structure for a charged atom, if you're writing Lewis structure for a charged atom, after you're done writing it, enclose it in a square bracket and put the charge at the top right side. This is what I mean. This was the Lewis structure for CO3 what? 2 minus. All the structure is done and dusted. But can I submit this guy? No. This is an ion, right? So I need to do this. If it is a neutral molecule, that means there is neither positive nor what? I'm not going to put this. I'll just leave it like that. But if it is a charged, either positive or negative, you must enclose it in a what? Square bracket. A compound that is neutral, you don't put a square bracket, you don't put the charge. This square bracket is telling us that this entire stuff is what we have inside. This entire stuff had how many charge? 2 charge, right? So this stuff is just enclosing what we have here. You cannot come and say, if you say this, does this make sense? Draw the Lewis structure. Draw the Lewis structure of 1 ClO4 minus. II SO3. Now let's start with this. It's after these two examples, I'll stop. I wanted to take maths today, but this guy will take it. Maybe after today, we're going to do a makeup. But like I said, the maths class, next week, we're really going to go far. Just that chemistry, the practical and the physics practical is what has made, and more persons are offering chemistry than some college are not offering maths. So that's why. So next week, I might dedicate one of the days of chemistry to math, because after now, I'm going to make videos. Please, the videos does not mean that I'm not still going to have the classes, right? I'm still going to make videos for the topics I listed, and then I'll go upstairs because some person missed out, and I cannot be doing makeup all the time. If I'm doing makeup all the time, it's going to be affecting us. So if you missed out, just go and watch it until when we now fix a makeup class where I'm going to teach it in class. All right, please look up. Let's solve for the first one. Please let me and be looking this. Once you stop, let me know. All right, please pay attention. These two examples, please, if you remember, one of my pattern or principle is that I don't have to solve 50 examples. Have I said that before? I don't believe in solving multiples, hundreds of examples. No, I believe in maybe explaining one or two very well. If you understand the concept, the problem most persons have is that you don't understand the concept. You just be dwelling on examples. I go to exam, so I change the question and you're confused. If you don't know how to drive Toyota, if I bring Lexus, can you drive it? No. Why don't you say it's only Toyota I can drive? Why? Because you understand the principle of what? Driving. If I bring Nissan, will you drive? If I bring Mercedes, uncle, I've never seen somebody that knows how to drive Lexus and they bring Mercedes, say, no, I've forgotten. How is it supposed to be like this? But why is it that when it comes to academics, you guys actually change the entire stuff upside down? So please, try and understand the concept. Please look up. What is step number 1? Identify the central atom, right? Class, between chlorine and oxygen, which of them is more electronegative? More electronegative. Oxygen is, please, the most electronegative element in the periodic table is fluorine. After fluorine is what? Oxygen, not chlorine. Now, if that one is going to confuse you, class, how many oxygen do we have here? How many chlorine? It therefore tells us that the central atom is the one that is 1. It means I'm standing at the center and I'm holding 4 stops. Not 4 things holding 1 thing. So this becomes a central atom. Chlorine is less electronegative than oxygen. So I'll come here. I'll ignore that one first. That one is not a problem. Now, I want to solve for my x. Step number 2 means calculate for x. Class, please listen. Let me emphasize on this much. X is number of shared electrons. Now, what did I say is x? Some years back, they asked them to just solve for the number of shared electrons. What did I say? They asked them to solve for the what? And most of them were confused. If you're asked to solve for number of shared electrons, it is x. Solve for your V and subtract from your A without dividing by 2. Without dividing by what? If you divide by 2, what are you now solving? Number of bonds. All right, step 1 is identify the central atom. Chlorine is a central atom. Now, number 2 is solve for the number of shared electrons. Whatever the answer for this x is, divided by 2 to get number of bonds. Now, what is my V? So I'll say for ClO4 minus. My V, remember I told us that V for every element is always 8. Apart from hydrogen, helium, lithium, and what? Beryllium. Every other element will attain octet configuration. Is it not so? So chlorine is going to be how many? 8. Plus, oxygen is going to be how many? 8 times how many? Please, this V is theoretical octet. Every atom undergo bonding to form octet configuration, just like the noble gas. That is the final destination when they form a bond. So that is why we said octet. Hydrogen is forming duplets. Helium will form duplets. Lithium will also form duplets, and beryllium. So this becomes 8 times 4 is 32, right? Plus 8 is how many? Please, my A becomes, A is sum of valence what? Electrons minus what? Charge. Sum of valence electron minus charge. And I told us that it will be very difficult for most students to remember valence electrons. Valence electron is same thing as saying group numbers. Is it not so? The group number of an element is equivalent to the number of electrons on the outermost shell, which is same as the valence. Valence electrons is the number of electrons on the outermost shell. Valence shell is same as outermost shell. Now, class, what is the group number of chlorine? 7. Class, what is the group number of oxygen? 6. How many oxygen do we have here? Minus. Class, what is the charge here? Please, the charge is minus 1. 6 times 4 plus 7. This is 31 plus what? 1. This becomes what? 32. Please, minus becomes plus, right? So my x becomes v minus what? A. Now, which becomes, our v is how many? A is how many? This is equal to how many? 8. So what if they had asked me the number of shared electrons? What's the number of shared electrons? Class, what this simply means is that this compound, chlorine, oxygen, the total number of electrons they are sharing with themselves is how many? 8. That's what it means. Now, number of bonds, I'll now say number of bonds is always x over 2. Is it not so? This is 8 over 2. That is equal to how many? 4. I might just even solve one example. So, let's do the what? But we are taking it step by step. I don't want to exceed 3 o'clock for this other class, no matter what. All right. Please look up. Stop. Just stop writing. I'm not going to clean this side. Just stop. Please stop writing. Number of bonds is 4. After this, I'm just going to stop. But so as math can continue, but I'm just going to go and solve more examples so that you can always check it out later this evening. Math has to go on today. But because a lot of persons are not offering chemistry, I'm seeing some persons in computer science and they've already come. So now look at this. Step 3 says, draw a skeletal structure of that guy with keeping in mind the central atom. This is the structure. The central atom is chlorine, is it not so? How many oxygen do we have there? So this oxygen will be scattered around the chlorine. Is it not so? That's the skeletal. How many bonds is this compound going to have? 4. That simply means, first, I'm going to use single bonds, right? This is 1, 2, 3, and what? We have exhausted these bonds. So this guy is not going to have a double bond. The next thing I'm going to do is, step 4 says what? Complete octet. Is it not so? Now, this oxygen is bonded to just one bond, right? One bond is how many electrons? 2. So these electrons would be counted for chlorine and also be counted for what? So this oxygen is having 2 electrons. So how many is short of being 8? 6. I'll add that as a dot electron. This is 1, 2, 3, 4, 5, 6. Same thing is applicable here, right? 1, 2, 3, 4, 5, 6. Same thing here. 1, 2, 3, 4, 5, 6. Same thing here. 1, 2, 3, 4, 5, 6. Rule number 4 is done. Number 5 rule says confirm or check to confirm such that the number of electrons on this guy, both the dot and the bond, is equal to our A. Our A is how many? Class, this is correct because each one is 8 electrons, right? 6 dots and 1 bond, that is 8. And we have this in how many places? 4. 8, 16, 24, 32. It's complete. So the next thing I'm going to do is to do what? Enclose it. And then we are done. Class, this will be the last example so that you can do maths. I don't want to exceed. So please, after enclosing it, what will I put there? Minus. So that is that for this guy. Now, if you're asked to solve something like this, if you're asked to solve this particular example, we have H, C, O, F. First thing first, you have to solve for your x equals to V minus A. Now, what is your V and what is your A? Now, please look up. We have 4 elements here: hydrogen, carbon, oxygen, and fluorine. And just like I said that, apart from hydrogen, lithium, beryllium, and helium, that attains duplex. That means the V for hydrogen is going to be 2. The V for helium is also going to be 2. V for lithium and the rest of them. So I'll come here. For this hydrogen, my V will be how many? 2. Plus, for this carbon, V will be how many? 8. Because apart from hydrogen, every other element will attain what? 8. Apart from hydrogen, lithium, beryllium, and helium. So hydrogen is 2, carbon is 8, oxygen is how many? Fluorine is how many? 8 in 3 places is 24, right? Plus 6 plus 2 is how many? 26. Now our A, which is sum of the group numbers minus charge, so I'll say sum of group number minus charge. Now, what is the group number of hydrogen, class? Hydrogen is in which group? Group 1. So the V for A for hydrogen will be what? 1. Carbon is in which group? 4. Oxygen is in which group? 6. Fluorine is in which group? Minus. Is there any charge on this compound? So this becomes what? 0. So the value for A, 4 plus 6 is 10, right? Plus 1, 11. Plus 7, how many? 18. I will now say x equals to V minus A. My x here is, my V is how many here? 26. A is how many? Please, what's the answer here? 8. Now, the number of bonds will be x over what? That is 8 over 2. That's equals to how many? So it means that this compound is going to have 4 bonds, right? Okay. Now, step number 1, we're done. Step number 2, we are done. Now, step number 3 says, give a skeletal structure for this guy. First, I told us that if you must give a skeletal structure, we need to know out of these 4 elements, which of them will be the central atom. Hydrogen cannot be the central atom, just like I told us previously, that hydrogen can never be the central atom because it can only hold 1 bond. Fluorine cannot because it is the most electronegative element in the periodic table. So between carbon and oxygen, one of them will be the central atom. Carbon is less electronegative than oxygen, you know so. So carbon will be the central atom. So I'll come here. I'll put carbon here at the center. I have hydrogen, oxygen, and fluorine. So I'll come oxygen, hydrogen, and fluorine. The answer we got, okay, fine, please, skeletal structure, not the bond first. This is step number 3. Let's use the compound to get a skeletal structure. Put the carbon at the center to flank the remaining atoms around the central atom. The next thing you're going to do, step number 3 says, from the chemical formula, draw a skeletal structure for this guy, which you have done. After which they said, connect those atoms using single bond first, right? So I'll come here, I put 1, 2, and what? 3. Out of the 4 bonds we got from our calculations, how many have we used so far? 3. Class, the rule continues. If there is a leftover, introduce a what? A multiple bond. If there is a leftover, introduce a what? It means that in order for us to take this bond to be equal to 4, we have to introduce a double bond. Is it not so? We have 3 different outer atoms, right? Hydrogen, oxygen, and what? Fluorine. So the big question is, where is the double bond going to go to? It cannot go to hydrogen because hydrogen can only hold how many bonds? 1. The bond is now between oxygen and what? Now let me tell us something, class. Oxygen, how many electrons does oxygen need to attain octet configuration? Oxygen has 6 electrons in the outermost shell, is it not so? It needs 2 to become 8. Fluorine has how many electrons? Fluorine needs how many to become 8? So if fluorine has just 1 bond, it has gotten that 1 electron it's looking for. Now let me explain why we are going to add the double bond to oxygen. Fluorine is in group 7. That means fluorine has 7 electrons in the outermost shell, is it not so? So with just 1 electron, fluorine will be very stable, right? And that 1 electron can be given to fluorine if fluorine should hold just 1 bond. Which, as we can see here, fluorine is holding just 1 bond. So fluorine is very, very stable. Is it not so? Oxygen is holding 1 bond, but is oxygen stable with 1 bond? No. How many bonds does oxygen need to be very stable? 2. Because oxygen needs how many electrons to complete octet? 2. Class, nitrogen belongs to which group? How many electrons does nitrogen need to complete octet? That is why nitrogen is always very stable with how many bonds? 3 bonds. So the number of electrons needed by an atom to form octet is actually what is going to help that guy to be very stable. So I'm not going to add the extra bond to fluorine because fluorine is already stable with 1 bond. Is it not so? Where will I add the extra bond? That is it. So you need to understand where the extra bond will go. I'm not adding it to hydrogen because hydrogen can only hold 1 bond. I'm not going to add it to fluorine because fluorine is very stable with just 1 bond. I'm going to add it to oxygen because oxygen needs 2 bonds to be very what? Stable. So we are done with step 3. Step 4 says, complete octets around each of them. Class, I'll go to hydrogen. On no account should you add a dot on hydrogen because hydrogen is always going to attain duplet, right? And by virtue of having a single bond, this single bond has how many electrons? So these 2 electrons is counted for this already. So hydrogen is okay. Now let's come down to fluorine. Fluorine will attain octet, right? Octet is how many? So far, fluorine is holding just 1 bond, right? 1 bond contains how many electrons? So how many dots will I add here? 6. So I have 1, 2, 3, 4, 5, 6. Let's move down to oxygen. How many bonds can we say oxygen is having? I did not say how many electrons. How many bonds? 2 bonds. Each bond contains how many electrons? 2 electrons. So we have each 1, 2 bonds. Each bond contains 2, right? So the number of electrons here is 4. Are you following? 2 from the first one, 2 from the second one. Is it not so? So how many electrons is needed to complete 8? 4. So we have 1, 2, 3, 4. Step 4 is done. Step 5 says, check to see that the total number of electrons we have here is equal to A. Class, what was our A value? So we want to check to see if this guy will give us 18. So let's check. This is 2 here, right? But before then, let's chill, class. Before I proceed to check, this guy, hydrogen is complete, duplet, is it not so? Fluorine is complete, octet, is it not so? Oxygen is complete, octet, right? Please do not forget to also check the central atom. Do not forget to also check the what? Is this guy complete octet? How will you know? Because this guy is having 4 bonds. Please look up. Each bond contains 2 electrons, right? This electron that is counted for hydrogen will also be counted for what? Carbon. So there is 2 here, there is 4 here, there is 6 here, and there's how many here? 8. So carbon here is also what? Complete. So the next thing I'm going to do, I want to check if the total number of electrons in this compound is equal to my what? A. What is A? Well, let's count. 2 here, 4 here, 6, 8, 10, 12, 14, 16, 18. Is it equal to 18? I'm correct. Now, am I going to add a square bracket here? I'm not going to add a square bracket because this guy is a neutral compound. It does not have a charge, right? So this becomes my Lewis structure. Please, I might just solve only A and then solve the remaining one. Now, see, first, let's find our V and let's find our A. Class, V for carbon, apart from hydrogen, helium, lithium, and beryllium, every other element will have a value of 8, right? So V for carbon will be how many? 8. V for hydrogen will be how many? 2. Times how many? 3. Oxygen will be how many? Plus hydrogen will be how many? 2. 2 times 3 is 6, right? 6 plus 2 is 8. 8 times 3 is how many? In case you're surprised how we got this, 2 times 3 is 6. 6 plus 8 is 14. 14 plus 8 is 22. 22 plus 2 is 24. Now, please, A is sum of group number minus what? Charge. What is the group number of carbon? 4. What is the group number of hydrogen? Times how many? What is the group number of oxygen? What is the group number of hydrogen? 1 times 3 is 3, right? 3 plus 1 is 4. 4 plus 6 is 10. Plus 4 is how many? 14. Now, step 2, let's continue. V minus A. What is the value of V here? What's the value of A? Now, X equals to how many? 10. I will now say number of bonds is equal to what? 5. The next thing we are going to do now is to actually get a skeletal structure class. Now, step number 3 says, from the chemical formula, draw a skeletal structure for that guy. Now, this guy is CH3OH. So what this, please look up. What this simply means is that, which of these will be the central, are we going to have any central atom here? Which of them will be the central atom? Carbon. I'll put carbon here. Class, look up. This carbon is holding 3 hydrogen. And also holding what? Oxygen. Now look at how this compound looks like. We have 3 hydrogens here. 1, 2, and 3. Then we have OH, O, and H. Class, that is a skeletal structure. That is a skeletal structure. From our calculation, the number of bonds is 5, right? So I'll put here, How many is that? How many? How many? Do not forget that this is an organic compound. So we've exhausted our 5 bonds. The next rule says use dot electrons to complete the octet. Class, I'm not going to add any dot to hydrogen because hydrogen is having just a single bond. Is it not so? I'm not going to add to this guy. I'm not going to add to this. I'm not going to add to this, right? Which of them am I going to add to now? How many bonds is oxygen holding? 2 bonds, right? One on the left, one on the right. Each of the bonds has how many electrons? So 2 on the left, 2 on the right. That's a total of how many? So how many electrons are we going to add to make it up to 8? So I have 1, 2, 3. I haven't done that. I'm going to look at carbon. I want to check if carbon is up to 8. If carbon is not up to 8, I'll look for a way to make it up to 8 by adding dots, right? But if carbon is up to 8, I'll do what? I'll leave it. So let's check. How many bonds is carbon holding here? How many bonds? 4 bonds, right? Each bond contains how many electrons? So if this guy is 2 here, this is 4, this is 6, and this is what? So is carbon complete? So this is done. Now the next thing I'm going to do, class, don't be in a haste. Always confirm if what you have, the total number of electrons is equal to A. Rule 5 says, check to see that the total electron is equal to A. Class, what is our A here? 14. Now let's check. This is 2, 4, 6, 8, 10, 12, 14. Is it up to 14? Is this guy correct? Will I put a square bracket? Will I do this? Class, you only do this for a charged compound. So since this guy is neutral, I ain't going to do this. So that's the Lewis structure for that guy. So I'll quickly talk about resonance. Please, these two, take it as an assignment.